Hello and welcome to the Omnex webinar, Advanced Quality Planning and Production Part Approval Process Integrated Implementation with AS9100. During this webinar, if you have any questions, please enter them into your questions dialog box in the GoToWebinar panel. Today's presenter is Dave Watkins, Executive Vice President for Omnex. Since 1990, Dave Watkins has been deeply involved in the evolution of APQP and the new product development process, working with aerospace, rail, and automotive industry companies to continually enhance launch performance and enable ongoing continual improvement. He is currently working with several major automotive and aerospace companies in this endeavor. This webinar is being recorded, and all participants will receive a link to the recording after the webinar. Take it away, Dave.
Good morning or afternoon or evening, everyone, depending on where you are in the world. I hope you are now seeing the beginning of the presentation. We were switching over from the scroll to the actual presentation. I thank you all for joining us. Always, these webinars seem to have a wrinkle that I haven't seen before, but anyway, you've seen a significant introduction to Omnex and all of our activities. My bio is not important other than to tell you that I'm the second longest serving member of Omnex's staff, and I joined Omnex after a pretty long industrial career, but that since joining Omnex, a major focus of my efforts, as the introduction said, has been in the area of new product development and introduction in automotive, in aerospace, in rail, in high-tech electronics and semiconductors. It's a passion of mine because it is the process in any organization that generates the revenue, generates the value. And I'll say at the very beginning that the purpose of incorporating advanced product quality planning into the new product development process and involving PPAP as a way of validating that process, all of the development work, everything from concept to cash has one purpose, and that is to enable the people in the production environment to be successful. That is to enable the value generating process and the people who work in it to be successful. So in that direction, the IAQG has, as you can read on your screen. Oh, let me say one other thing. This is a pretty dense webinar in terms of content. I will be moving fairly quickly, so I would urge you from the beginning to plan on going to our website. You will be able to either view the webinar again or page through the slide presentation at your own pace to review it. So I'm going to be giving you sort of the gist of it, and then, as I say, I'd urge you to visit our website at no cost. Just flip through the slides at your pace so you can read and consider and ruminate and despair, whatever your reaction is. The intent of this webinar is really to try to prevent a repetition of some of the major failure modes that the automotive industry experienced when it went down this road, and to, as I have been doing with aerospace clients that I've worked with since 2007 is the first full-time engagement. There were a couple before that, but all the time that I've been working with aerospace companies, I've been trying to deliver this simple message, which is don't do it the way the automotives did it. The system and the process is good, but the approach that was taken was not. And I'm going to be touching on that towards the end, the lessons learned and the ways to avoid the hammered thumb that comes from not learning a lesson. I'm going to very briefly talk about the project background, meaning IAQG, the International Aerospace Quality Group, took this on as a project to develop an industry standard for incorporating advanced product quality planning and production part approval process into aerospace company new product development processes and the management of ongoing continual improvement. So a couple quick seconds on that. Then we'll sort of take a walk through what the standard has articulated as the aerospace approach. And I will tell you that it is very similar, but not exactly the same as the automotive and other industries, by the way. I'll make that other comment right at the outset that APQP is becoming a norm. A version of APQP is becoming the norm in almost every major industry that we interact with. It's like the virus got out there, and now all these major industries have been infected with it. And part of it, I think, comes from simply looking at the parking lot and saying, you know what? That's pretty good stuff out there. The car I'm driving is a pretty good car. The other cars, they're well engineered, they're well manufactured, they're on time, they have a high level of product quality, they have a high level of durability and repeatability in the main, and maybe we can learn something from that process. So it is not only aerospace that is adopting an approach to APQP and PPAP, and we're going to see that there are some things that are common and some things that are not. So looking at it from the background, the concept of advanced product quality planning obviously evolved in the major North American automotive companies, officially released as a document, a guidance document, in 1994 as a companion to the Automotive Quality Management System Standard QS 9000. And a PPAP manual was issued at roughly the same time, and that PPAP manual was adopted as a standard rather than a guidance document. So it became the minimum set of requirements for automotive APQP. AS9145 has been created and issued in aerospace to develop a standardized approach to advanced product quality planning and PPAP in aerospace. The thing to understand about APQP, and this is one of the lessons learned from automotive, is that it is not a separate process. It is not the responsibility of the quality function. It is a fully integrated, cross-functional, multidisciplinary process. It is, in fact, risk management activities that you integrate into your new product development and launch process and your ongoing process control and continual improvement strategies. It is not something you assign separately to other people to do as an adjunct to new product development and launch. That will produce a bunch of useless paper. It is literally a disciplined approach to try to ensure that we minimize launch risk, that we minimize the risk of being late, minimize the risk of not being able to produce conforming product at the promised rate or the demand rate of a production PO, and that we do not have escapes. We have a process which is capable enough to predict very low variation and very low process failures, and contains what escapes or what failures do occur rather than having them escape. Those are the keys to customer satisfaction, as you all know. But another misconception I want to address right up front is that last bullet point. PPAP is not a process in and of itself. It is the output of the APQP process. As you go through new product development and launch, you perform the various activities prescribed in AS9145. You generate the various deliverables required in AS9145, and at the end of the process, you do a trial run and you assemble the evidence from that and all the prior documentation. So the PPAP is an output of the APQP and new product development process, and it is certainly not the objective. It's simply evidence to demonstrate that the process and the product are capable of consistently meeting all the customer's requirements. The thing about APQP is it is an organizational discipline, meaning that you can comply with requirements without achieving the desired results, or you can invest in the process and achieve the desired results. So if you look at this little graph, the dollar bills are to suggest that what you invest up front will minimize what you pay at the back. Meaning, if you left shift your resources into planning and analysis and development of processes and strategies to control those processes, you will minimize the cost that you spend in the back end on inspection, appraisal, test, correction, and customer returns and rejections. The box at the bottom is a little mantra of mine. Prevention is a one-time expense. Detection and correction go on forever until we learn what causes a failure and learn to control that cause. We will be having to inspect for it, find it, and either rework it or scrap it and remake it or get it back from the customer and remake it. By the way, I neglected to mention at the start of this rant that there is a questions box in your little dialog box on the right, and if you will enter questions there, because your phones will be muted throughout the presentation. With as many people as we have online, we cannot open up the phones without achieving instant chaos. So instead, if you'll write your questions in, I will be monitoring them, an associate of mine will be monitoring them, and as time permits, I will try to respond to them as we go along or in a short break in the middle of this. Now, back to that graph, because that graph is important. The thing to focus on is that red dollar sign never goes down. As long as we don't learn to control and prevent variation and defect generation, we will continue to accrue expenses associated with those defects. That line will go up. It doesn't level out. It continues to go up as long as you're producing that product. Okay, so let's take a look at what the aerospace industry has defined as the APQP process in AS9145. Bear in mind that part of the object of going through this process to develop and deploy this standard is, again, to try to protect the industry from something that went on rampantly in the automotive industry before they developed APQP as a standard, which was every customer had their own set of expectations and requirements. I had a quality manager who worked for me once. I went into his office, and he had a bookcase, and along the top of the bookcase were like literally 30 3-ring binders. And I said, "What are those?" And he said, "Those are the quality management systems for all of our customers." Meaning that every customer we had in that job shop had their own quality manual and their own expectations and their own requirements. And this guy had 2 people on his staff whose full-time job was entertaining customer audits. Year-round customer visits and customer audits. And every time we developed or shipped a new product, we had to go through a unique set of requirements. The aerospace industry has already started down that road to a certain extent. A number of major players have already developed their approaches to APQP and their expectations for PPAP. Fortunately, up to this point, they're relatively similar, but that could change at any time. And if you're a supplier to multiple aerospace customers, life will get really miserable if they all have a different set of requirements for APQP and PPAP, particularly PPAP. So this is an effort by the industry to establish standardized requirements, and by standardizing them, hopefully result in the elimination of, or at least the reduction of, organization unique requirements and the resulting variation that suppliers and organizations in the aerospace value chain will be stuck with trying to satisfy multiple sets of expectations. So what the APQP model in aerospace does is specify in the new product development process activities that go across all of the functions and all of the suppliers with associated deliverables and interim approvals at defined points or gate reviews, meaning that APQP is not a quality function or a uniquely engineering function or a sales function, that the various activities and deliverables engage and at various stages by definition require cross-functional multidisciplinary solutions. The object here is to not have APQP be a separate process, but to have it align with and be integrated into whatever your organization's approach is to product development and ongoing process control and process improvement. APQP is at its heart 2 things. It's a risk management set of disciplines or it's a set of risk management disciplines, and it is a knowledge management system. It's a system designed to develop and deploy and sustain and continually improve our understanding of our technologies, of our products and our processes, and to make that knowledge and understanding available to anybody engaged in activities in the company that need to be aware of and understand it. It is not documents. It's not forms and records. It is a system. So the way that aerospace envisions it is the same way all organizations do, actually. The development and launch system that we deploy typically has phases, although in reality a lot of those phases are becoming concurrent and even cooperative and integrated. And so phase is really almost a term for a part of the process rather than a timing of that part. And each of those phases is really defined by what the elements are. For example, you can and should be developing a design. If you're design responsible, you should initiate a design failure mode and effects analysis with the start of creating a detailed design. In fact, the image I have for that is a DNA molecule. You've got the two strands of the helix, and they're connected by risks and controls, so requirements and controls, and they evolve together. So that evolution of the DFMEA should be occurring with the development of the process. And the process FMEA, they're linked, they share information, they share understanding, and they should be cooperative and concurrent. So even though the picture may show the phases as being at different times, in the real world, they're evolving into being concurrent and cooperative. Maybe one of these days we'll just call it development and leave it at that. Each of those phases, though, has elements that define activities and then deliverables. And many of those deliverables then become evidence in a PPAP package. So if you look at the picture of the model that IAQG has adopted, it's the V model, which is a sort of more modern iteration of the classic cascading model, so that the right-hand side corresponds to the left-hand side. But it basically is modeled on the product development process from concept and kickoff to the end of concept, when we have a plan and we have a concept design and we have a defined or at least a planned manufacturing process. We've made key sourcing decisions, and then we move into product development and product design and development and process design and development. And the effort these days is to get those two phases to be as concurrent and cooperative as possible. There's a point at which we have a design which has been validated and a process which is ready for validation. And at that point, we move into the phase called product and process validation, which is to produce parts, do an FAI, do capability studies, engineering testing, and do it at rate in a serial production process that is predictive of what will happen when we evolve into production. So it's defined in terms of 5 phases. The duration and the interconnectedness of various activities will, to a large degree, depend on your organization, your products, your customers, your suppliers. But the elements and the deliverables will not significantly change, just the timing or the sequence, perhaps. So you see this, oops, sorry about that. You see this process, and then on the right-hand side in that graphic is simply the graphic from AS9145, which lists the production part approval process, and on the right hand it refers to which section of this overall APQP process generates those. So one of the things, if you just glance at it, don't study it at the moment, but if you just glance at it, you'll see that a lot of the deliverables are early in the process, some are in the middle of the process, and not that many are at the very end of the process. So it is not a thing that you wait until the end to do. So let's take a quick walk through the phases. And I do mean quick because I don't want to take up your whole day with this. You have other things to do. The first phase, not surprisingly, is the most important phase. And the reason I say that is because it is the phase in which we determine requirements, customer expectations, all the requirements related to the product and the process. That ranges from all the end users, the direct customers, the suppliers, the manufacturing processes, the legal and regulatory environment, all the requirements, and assessing, understanding, and managing those requirements, doing an effective technical risk and feasibility assessment, developing a plan that will enable us to achieve the launch with a product that meets all the customer's requirements and with a process that is sustainable, predictable, and capable. If we don't do phase one right, we are not going to get the other phases right. It's that simple. The biggest issues that I run into consistently are a lack of effective approach to requirements management and to technical risk and feasibility assessment prior to bid. I'm sorry, I misspoke. Prior to bid, before you commit legally, you need to know what it is you have to do and how you're going to do it and what the risks are and what potential feasibility issues there are and how you're going to resolve those. If we move on then to phase two, and I really talk about phase two and phase three at the same time because phase two has to do with developing a detailed product definition, all of the data, information, graphics, whatever, required to enable the production process to produce the product, and that does that in the context of that production process. The development activity comprehends the process that's going to make it, and the owners of the process that's going to make it participate in the product design and development to ensure that the two things are compatible, that the design and the process can actually be successful. The output at the end of phase two is the product definition. Phase three, hopefully, has been going on right along, and the output of that is a production process, manufacturing, assembly, whatever is involved in production, but not just the process, but the system that has been developed to control that process. And that's really the output of APQP. The output of APQP is a comprehensive system for operating the process, controlling the process, continually improving the process, ensuring its ongoing capability, predictability, and enhancements to that performance as we learn, as we move along. Phase four is a verification and validation process in which we do a significant production run, and that's going to vary all over the map depending on what kind of products you make and what your volumes are. One of the challenges in aerospace in dealing with this is the challenge of low volume production, and how do you verify and validate the capability of a process that does essentially low volume production. And there are methods and there are workarounds, just as there are in automotive. There are automotive products that are very low volume. You're not going to do a PPK study on a 750 horsepower diesel engine block. That would require you to make 600 of them to do your dimensional studies, and that's not going to happen. So you have adaptive strategies for determining or predicting the relative capability of the process. That being said, it is hugely to the advantage of the producer to know what the capability of that producer's process is, to be able to predict what outcomes and yields and throughput rates, et cetera, are going to be, and to be able to manage that. Without that knowledge, the likelihood of consistently satisfying your customer's requirements and expectations is frankly pretty slim. And your likelihood, even worse, of making money on it is almost nil. I watched a rail launch in which the first vehicle build in FAIR for a train system, they discovered they had to make 825 engineering changes to the one rail car. That added 50% to their overall engineering budget and delayed the launch of the vehicle by 3 months. And then after it was launched, there were myriads of other engineering changes. you can imagine it will be a while before the producer of that rail system is going to make any money on it. So phase 4, the product and process variation, this is where we generate the outputs that become the PPAPs, that become part of the PPAP package. So we have initial capability studies, we have initial production, part validation, testing, we have the first article inspection that you're all very familiar with, and then the additional documentation, the DFMEA if you're design responsible, the process flow, PFMEA control plan, MSA studies, capability studies, process readiness reviews, all of that become, all of those things that we've developed along the way become part of the PPAP package. And the last, or it's hard to say last, the final phase that begins at launch and continues for the life cycle of the product is ongoing production use and post-delivery services, where you have contracted post-delivery services like MRO or something of that nature. But it is a discipline which is much neglected in the APQP world, particularly historically in the early days of the automotive industry's deployment of APQP, which was as soon as they'd submitted that PPAP package, it went into a file folder, never to see the light of day again. And they moved on to the next problem, which meant that whatever that process was, it wasn't going to get better, and it was probably going to get worse. And they were going to be dealing with variation and internal scrap and rework and customer rejections, rather than focusing on the process and continually improving it so that it would avoid those outcomes. I've mentioned several times things like DFMEAs, PFMEAs, process flow diagrams, control plans. Those are the knowledge management architecture of APQP involved in planning, analyzing, making decisions about, and then implementing controls on the design process, the manufacturing process, the actual production processes, and they are linked. One of the objectives of that linkage is to pass from the customer to the machine operator an understanding of the elements of the product that they're working on, the risks associated with that, how to control them, how to prevent failures, why you're asked to do certain things the way you're asked to do certain things, is derived knowledge from this cascading from the initial project inputs right down to the machine operator and the inspection checklist, transferring knowledge beginning with requirements intake and detailed design development right down to machine setup and operation and control of the process. With ultimately with records and data that can loop back into the process FMEA to continually improve the performance of the process, can link back into the DFMEA to continually improve our design processes and reduce the risk of design-related failure. One of the questions that every organization is struggling with related to APQP and PPAP is application. Technically, the standard itself applies to any new product development effort. Changes to existing products, either the design or the production processes, final product or selected levels of parts, that is within components to subsystems to higher level systems to the highest level systems, and how APQP and PPAP will be applied at those various levels and channels when previously approved products or processes undergo change or simply failure. One of the triggers that a number of companies employ to invoke PPAP on a product is when there is significant failure, when there are significant escapes or functional failures. The decision is made that that's more risk than we're willing to continue to accept, so we're going to invoke PPAP on that product and expect that the vendor of that, the supplier, go back sort of to the beginning and work their way through the process flows, FMEAs, control plans, etc., and a production run with PPAP to verify that the risks that have already been experienced have been brought under control, but not only those risks, but other related risks. So what is the question? The question is how organizations are doing this, because If you simply said, okay, from this date forward, every PO that goes out is going to have a APQP PPAP requirement, it would be a challenge, shall we say, to the industry, to the customer, to the suppliers, to have the knowledge, to have the techniques, to have the technologies, to have the resources to plan for and conduct this. So various organizations are adopting a variety of strategies for this that can be based on very high-risk programs, high-risk systems, work transfers from one supplier to another, from one region to another, but it will always be up to the customer to invoke production part approval process. The organization itself is always at liberty to invoke advanced product quality planning and integrate it into its system, and even to have internal PPAPs. I know of any number of companies where they have one facility that produces components, ships them to another facility that produces other components, and then assembles them. And the internal move from one plant to another is governed by a required PPAP. That is a policy decision that that organization can make. But industry-wide, in general, what is happening and what is going to continue to happen is that various airframe and top-tier suppliers are deploying their approach to APQP and PPAP, invoking PPAP as a requirement on targeted products, systems, components, work packages, whatever the case may be, based on their policies and their assessment of risk. Where you do not see it being regularly applied is in COTS and commercial off-the-shelf items, and then the ongoing discussion of how it gets cascaded to sub-tiers. Generally, the industrial requirements are that if I, as a customer, invoke PPAP on you and you're supplying me with a subsystem or assembly and you're doing it with purchased components, I'm going to expect you to cascade APQP and PPAP to your suppliers of those components the same way that you do FAI. That is a general practice. It is not a rule. The standard at this point doesn't require it. The automotive standard, on the other hand, does. It does require that IATF certified companies cascade APQP and PPAP and the requirements for IATF certification to their vendors. But as yet in aerospace, that's not the case. In terms of scope, this is simply saying that IAQG publishes distinct standards for things, and in order to comprehend something, you generally have to put it in the context of those other standards. So this is pointing out that AS9145 is intended to and does integrate and collaborate, if you will, is coordinated with requirements in AS9100, AS9102 first article inspection requirements, AS9103, which is the variation management of key characteristics. The flow of key characteristics through APQP is a principal focus, actually, of APQP, and 9110, which is requirements for aviation maintenance organizations, where there are AS9145 requirements that extend to MROs. That said, the requirements in 9145 are complementary. They do not override requirements in the other standards, and they defer to contractual and applicable statutory requirements, regulatory requirements, which is to say, obviously, if your customer, as part of your contract with them, requires something else, you comply with the something else. You comply with the contractual requirement. It's an underlying requirement of AS9100. So, a quick look at Aerospace PPAP. As you will recall, PPAP stands for Production Part Approval Process, and where we say for product requiring PPAP, we mean where Production Part Approval Process has been invoked by a customer or by an internal policy requirement. So here's the deal with PPAP. The vendor, that is the supplying organization, and the customer agree on the basis of the program what the applicable elements are in PPAP. Don't misunderstand that. All the elements are required unless an element is not applicable because it's an activity that the organization doesn't perform as part of its business, such as if the organization is not design responsible, then the element for a design failure mode and effects analysis is not applicable. In general, all of the elements are applicable. The variants on that in some standards have been for things like an appearance report. And if a supplier, the product being made doesn't have any appearance requirements, then the appearance report is not applicable. Or the use of an engineering source approved external process or frozen process. If that's not applicable to the particular design being made, there isn't an engineering source approved supplier or a frozen process, then those elements are not applicable. That's what's meant by not applicable, not we decided not to do it or we agreed with the customer that we didn't have to do that. The standard expects that all applicable requirements will be performed regardless of what the customer wants to see, by the way. We're getting into the issue of submission, and there's an endless amount of confusion associated between what are the things that are applicable and I have to do, and what are the things the customer has said they want to see and I have to submit. They are not the same thing, typically. So we have to be very careful not to get confused between what is applicable and has to be done and maintained on file and what the customer has required in a submission. So what going on with what is required is, as you work through the new product design and development and launch process, at various stages there are activities that are required and deliverables that are required, so you develop a record of those things. This refers to a file. It doesn't necessarily literally mean a file. The documents can be at various locations just as long as they're accessible. If you've got them in document storage sites, as long as sitting somewhere with a customer or an auditor, you can access those things to share them with that customer or auditor. They don't have to be in a file. They have to exist. They have to be accessible records. When your customer says, you have to submit a PPAP, and these are the elements I require you to submit, that's what you submit. You have to maintain the file and ensure its accessibility regardless of submission level. The customer may say, I only want to see the approval form on the top. But if they called you the next day and said, hey, we've got an escape and we're going to come down and visit your plant, we want to review the PPAP file, you better have the whole thing. Otherwise, it's going to get tense. Notify the customer of product or process changes. This is a PPAP specific, APQP specific thing, which is once you have an approved PPAP on record for a part, if you plan to change anything, essentially, and you can refer to AS9100 for what we mean by anything, but anything that could have a material impact on the form, fit, function, reliability, durability, safety, et cetera, et cetera, et cetera, of the product, anything that could affect that, a process change, moving a machine, moving a tool from one type of machine to a different type of machine, anything like that requires prior notification to the customer. And that's not to say you can't make the change. It's to say they get the right to determine how much risk they think is involved in the change and how much PPAP evidence they want to resolve that risk, to mitigate that risk. That will be a thing as this gets rolled out, the issue of notification, prior notification, and then review and approval. And the last bullet, when PPAP submission requirements are not fulfilled at the time, there has to be a plan for how they're going to get fulfilled. As long as there's a plan and the customer agrees to the plan for fulfilling the gaps, then the customer will probably issue an interim approval to the PPAP. But if a PPAP submission is incomplete without explanation or has things in it that are wrong without explanation, that's going to lead to a turnback or rejection, and the industry will over time become extremely intolerant of that, to the point at some point in the future I can forecast it'll get to where the automotive industry is, where basically, if you have a rejected PPAP, you can expect to lose your approved supplier status and have to go through an elaborate process to regain it. So that if you're, for instance, a supplier to Ford and you have Q1 status and you get a rejected PPAP, likely they will pull your Q1 status and make you start over again as an approved supplier. So the file that I've been referring to and the submission, the basic elements are in the standard. I've got the little box here that shows them. And it's not huge, but it is significant in terms of activity. You need to, if you don't already have it, to get the standard and review each of these elements in detail and make sure that you understand them in the context of your organization and your relationship with your customer who may be imposing or invoking PPAP and the whole APQP process requirement. So you have change PPAP submissions, which are very much like a Delta FAI. When there is a change as characterized in AS9100, the customer can require obviously a Delta FAI, but also an updated version of any affected documents or records in the PPAP submission. Bottom line, and this is an auditable thing for those of you who are AS9100 certified or certified to some other international quality standard that recognizes PPAP, the current PPAP file has to reflect the current process. This is auditable. An AS9100 auditor who comes in and says, do you have any customers who have invoked PPAP? Yes. What products? You'll tell them, and then they will want to see the PPAP files, a sampling of the PPAP files for some of those to demonstrate conformance. The other big chunk, you understand this, is the FAI report. It is a part of the overall PPAP submission. There are companies that are requiring additional things in an FAI as part of PPAP, such as multiple dimensional reports for multiple parts, capability studies that an FAI doesn't require. But they all require a complete and approved FAI. When you look at all this in the context of AS9100, AS9100 basically points at operational risk in 8.1 and throughout the 8 section, 8.2, 3, 4, etc., it's addressing risk. What APQP does is formally address that risk in a process. So much of what you see in APQP corresponds to requirements in AS9100. So there's the AS9100 structure, the high-level structure around which a AS9100 QMS is developed, and where do and how does AS9145 and PPAP fit in? So it seems like a reasonable question. You've got this diagram, you got this picture, you got all these elements, and the numbers of the elements don't correspond to anything in AS9100, inconveniently, but that's the way it is. So how do they fit? Well, they fit kind of like this. Planning, whoops, the arrows got crossed. Planning in phase 1 refers to 8.1. Planning aligns with 8.1, operational planning and control, and requirements for products and services. So 8.1 and 8.2 requirements management and planning correspond to the phase 1 of APQP. Phase 2 of APQP, the arrows definitely got reversed. Phase 2 of APQP aligns with design and development of products and services. Now, AS9145 does not have any manufacturing process design and development requirements like the automotive standard does. The automotive standard has a design and development requirement for manufacturing, which completely mirrors the product design and development process. AS doesn't do that. However, phase 3 of the APQP process does, and it prescribes those things you do to ensure that you have an effective, comprehensive system for managing and controlling your production process and for mitigating or eliminating production process risks and controlling those. Phase 4, PPAP is an event that occurs before production, and it corresponds with FAI. It is simply a significantly more robust version of FAI, but it occurs at much the same time. It's the bridge from development to serial production. It's the gate you have to get through to transition from development, both product and process, and serial production. There are aspects of this that when you build them into your system, they are going to enhance its effectiveness. One is, do not treat APQP as a separate process, integrated into your new product development process. Just plug in the activities and the deliverables in the appropriate place in your product development and launch process. It will make that process more robust, and it will also make the APQP elements absolutely relevant. If you fob off APQP activities on some department, like the quality department, then you'll have them doing a lot of useless, non-value-added paperwork. I would suggest avoiding that. Define a structured process. If you haven't already, and every organization in aerospace that I've gone into actually has a well-defined, relatively mature system for developing and launching new products. So with that, make sure that it is multidisciplinary. Where I see weaknesses, and this will come up a little later in the presentation, where my associates see it, is at the very front end, where the planning and the technical risk and feasibility assessment, the quoting process, if you will, is not engaging, excuse me a moment, where that process of getting to a plan and a bid is not effectively engaging product engineering, manufacturing, supply chain management, purchasing, program management. I've seen projects, major project launches, where the first time the program manager and the cross-functional team that manager has, the first time they see the project is when there's been a notice to proceed, the contract's been awarded, and the project is handed to them like a football, and they say, okay, here you go execute this. And they've had nothing to do with it up to that point. They did not get to be involved in doing the risk and feasibility assessment. They didn't get involved, they weren't invited to be involved in supplier risk decisions, sourcing decisions. They're just given this ball and told to run with it. That's pretty much a recipe for failure. Clearly defined gate reviews with timing, risk, and budget. Now, careful. That does not necessarily mean that at the end of phase 1, you have a gate review. At the end of phase 2, you have a gate review. At the end of phase 3, you have gate reviews at the frequency you determine appropriate, at the times in your process that you determine appropriate, and in all likelihood, that's going to be more than just one at the end of each phase. When I see organizations doing the gate review at the end of each phase, I see them looking in the rearview mirror. They're trying to drive the project using the rearview mirrors because they're looking at what went right or wrong or what has to be fixed or whatever that was red coming out of the previous phase. They're not looking through the front windshield to see what they're going to do to ensure that the next phase is successful. It's too late. If you wait till the end of the detailed design and development, and none of you do, by the way, but if you wait till the end of the detailed design and development process to review it and say, are we okay, you're going to be so far behind the 8 ball, you would be, and that's why you don't do it. But also, it's not smart to say, well, we will wait until we have an approved, validated design before we start to work on the process. That's unrealistic, it's unlikely, but as a disciplined, managed process, we do see that sort of thing. Throw the plane through the transom and let them catch it on the other side and say, okay, it's up to you now. Here's your design. Go build it. That generally is another recipe for disaster. The management of critical items and key characteristics. This is risk management knowledge. It's cascaded down through the system so that an operator won't be like one that I was talking to in an FMEA meeting at a site one day where they had a feature on the part and we had a product engineer sitting in, and the question was, if this feature is out of tolerance, what will be the functional effect? And the engineer involved said, boom, meaning it would result in a catastrophic failure. The operator of the process, the owner of the process, the people making the part, none of that was understood by any of them. And therefore, they didn't have anything nearly like the robust enough controls on that feature to prevent that failure. You can extrapolate that to any number of contexts and failures. The point is that the knowledge of the associated risk and how we are controlling and mitigating that risk is not conveyed right down to the machine operator. We're going to get high-risk failures, and frequently we're not even going to know about it because the operators may be measuring the part, it's a little off, remachine it a little bit, it's still a little off, remachine it a little bit, and now it's okay, and send it on, having done things to the microstructure and what have you that we don't know about and that our customer isn't going to know about, and those are not good things in airplanes. I think it's fair to say that from years of experience with this, your organization needs to find an appropriate software solution for doing this work. It is simply too difficult to do using Excel or whatever, SharePoint or things like that, and traditional Microsoft Office products. Not to demean them, they just weren't made for this, and they don't support it. We have produced and deployed products that do this since the 1980s. There are other products. You have to get a software solution to support this. One of the things that having that kind of a solution will do is to maximize your ability to reuse, design, and process solutions, because they're captured in FMEAs, they're documented as process control strategies for prevention of design risk and for prevention of process risk. And the more iterations we go through, the less we have to think about it, frankly. We know what to do and how to do it. But it takes building. You know, when I tell groups that I work with or clients, the first time through this, it's like building a pyramid. The first level takes a lot of work because we're starting from scratch. But every iteration after that, the amount of work and the time involved becomes less and less. Think Mayan pyramid with the big step ups, not the Egyptian pyramids with the little steps. Mayan pyramids, big steps, so that after 2 or 3 iterations, the amount of additional development work to be done is minimized and overall product development launch cycle time is reduced. So, how about we avoid things that we know went wrong? You see my little guy down there in the corner with the sore thumb? Every digit on my system has that kind of damage to it from 30 years of being involved with this and making all the mistakes, I think. Oh, God, I shouldn't say that. Making most of the mistakes it's possible to make. The first worst is when the leadership of the company perceive APQP as a quality function, say, go handle it and come back and tell me how it went. That is absolutely going to guarantee failure. In phase 1, not performing robust, really robust technical and program feasibility and risk analysis prior to bid just pretty much guarantees cost overruns and timing overruns when we run into risks and feasibility issues that we didn't anticipate. And when they pop up, we go through design iterations, we go through process iterations, it takes time, it costs money, and we're late. That's pretty much guaranteed. Not involving manufacturing and program management in the initial planning and quoting process, what I just ranted about a couple minutes ago. That's how can you not engage the people who are going to have to execute? However, it's a very common thing that this happens, that programs are planned, bids are submitted, business is awarded, and then the people who have to execute are invited into the room and told, okay, here you go, this is what you have to do. Manufacturing and purchasing are not involved in the design and development process. They're going to have to make it, and purchasing is going to have to source the materials, etc. You should engage them at every design review as you work through detailed design. And as manufacturing is doing manufacturing process design and development and doing PFMEAs, they absolutely have to have somebody from product engineering engaged, whether it's remotely via internet meeting or it's in person by being at the plant. By the way, if your product engineers have not been to the plant, probably a good idea to get them to go there. They might absolutely learn something, like how the product they're designing is made, which is useful to know. But seriously speaking, you need to engage product engineering when you're developing the manufacturing process. Product engineering understands the functions and the risks associated with functions that the production process might well not know or not understand. And when they're doing their PFMEA without that kind of input, they're going to have problems. The interfaces and sequencing between the tools. You have different people being assigned to do things out of sequence, and there's some sequence that are essential. You cannot develop a process control plan without having already conducted a PFMEA. One is an absolute precursor to the other. If you do, you'll have an inspection plan, not a process control plan. You cannot do your capability studies and your dimensionals for FAI without having previously done the MSA and Gauge R&R studies. Other failures that have hurt a lot are inadequate supplier risk assessment. In the pursuit of low-cost suppliers, every industry I've been exposed to has more than slammed its thumb in the car door over low-cost producers. In the pursuit of low-cost purchase price and not recognizing that the cost of ownership is going to be significantly different because of a lack of supply chain risk assessment, supplier selection, supply chain performance management, and continual improvement. Not involving the suppliers in your process. When you're doing a PFMEA where purchase parts and components are involved, it pays to engage your supplier, and vice versa. When your supplier is doing APQP on a part they're going to provide to you, it will pay to go engage in their process. Little engagement in APQ by individuals. This is back to the idea that organizations think APQP is a quality thing, and they give it to the quality department, and the other functional areas that play a major role in new product development launch do not get engaged in it. Gate reviews are not done, or if they are done, they're just assignment meetings. They're meetings to make sure that people know what they're supposed to do. They're not evaluating quality of the event. They're not evaluating how well something was done and how well it contributes to the process. Doing actual risk analysis and then assessing or evaluating the effectiveness of strategies that are implemented through PFMEAs, through discipline problem solving, not identifying and addressing risk at each phase review. These are all common errors, and they are significant. So, in summary at this point, so I leave myself a few minutes to answer questions, it is clearly demonstrable with data to support it that APQP and PPAP will improve overall quality in the aerospace industry. Automotive suppliers, I know you get tired of hearing about this, but automotive suppliers have gone from thousands of ppms to hundreds of ppms to under 10 ppms to some first-tier suppliers counting PBMs, PPBs, parts per billion, because they don't produce enough defects to count parts per million, or in general across the first tiers of the automotive industry, all the suppliers are under 10 parts per million. They did not get that way by working harder. They got that way by employing APQP and effective risk management and continual improvement. The aerospace industry, I have been in suppliers whose PPM levels or defect levels, however you want to count them, range from 1,000 to 20,000. I've been in some that were well above, well north of 20,000. They need to be and ultimately will be under 100. They will at some point be below 50. When you think how many parts and components go into an aircraft, A PPM level, if every supplier is at 200 ppms, you won't be able to fly. As someone told me in one of the engine companies, they said, if all of our suppliers perform at 200 ppms, we will not have a single engine on the line that does not have at least one defect in it. And that's intolerable. That the flow of product, the assembly of product. So PPM levels have to get to south of 100 for this industry to really be able to thrive at a cost competitive and speed. It's the amount of speed that's lost in this kind of variation. APQP with project management and gate reviews will help to ensure on-time delivery of projects. Not just products, but overall projects. This industry has a track record of every new program being chronically late. I don't need to tell you the stories. You know them. You've actually been a victim of them or part of them because it's chronic. APQP tools like DFMEA, PFMEA, process control plans based on PFMEA and requirements, MSA, process capability studies will improve initial quality as soon as they're done effectively, as well as supporting continual improvement. If you have a defect level, internal scrap and rework level on a given manufacturing process, the only way you're going to bring that down is by the effective use of PFMEA, at least in our experience. You cannot go from 60 defects a month to 30 defects a month to 15 defects a month on that line without employing these systems. And then APQP, PPAP are an insufferable chronic issue in the early days in the automotive industry, and one which is present now in aerospace is companies doing PPAP without doing APQP. Meaning, at the end of the day, they're filling out forms to put into a folder at the last minute in order to submit a PPAP. And the work that needed to be done to develop the product and the process in APQP wasn't done, not in any relevant manner. But at the end of the day, they think they're doing all right because they're filling up a folder with documents. That's disastrous. Lack of competency at all levels of the industry to do these things, that all of the organizations I engage with are struggling to develop and maintain the kind of SMEs who are competent in design and process FMEAs, in the development of effective control plans, in performing measurement systems analysis studies, in appropriately employing statistical process control, and in effectively developing production part approval process submissions. It's not just the people who have to do it at the supplier, it's the people who need to be competent to evaluate it at the customer and who need to be competent to help the supplier. As these systems get deployed from the highest tiers, from the airframes, OEMs, as they get deployed at each level, that level needs to have supplier quality engineers or whatever term we use for them who are competent to help the supplier develop APQP effectively and who are competent to evaluate the outputs of APQP. And whatever hook, crook system, you need a solution, a software solution to automate and make much more efficient the process, conducting these analytical processes, developing the control plans. This is not a matter of typing and filling out forms. This is supporting linked documentation, common databases, inheritance and efficiencies. And we have a solution to this. We'd be happy to share it with you, but you need a solution. So with that, the process cycled before, and you saw all these slides, so I'm now going to move to the questions. Okay, one question is, would approved PDR, CDR be? No, but that answer would require some more detail than I can give you. Let me see, are there other questions here? Okay, we've actually got some questions showing up. I'll see if I can answer them. Is there a way to get the PowerPoint slide deck? There's not a way to get it. There is a way to view it. If you go to the Omnex website, there will be things you can click on that will get you to the slide deck, and you can page through it at your leisure. In other words, take as long as you want to read each slide, or you can view it as a recording of this webinar, so that will come with this utterly brilliant commentary you've been enjoying. So if you want it with the commentary, you watch the recording. If you want to dispense with the commentary, then you flip through the slides and read them at your leisure. But the only way to do it is by going and visiting the Omnex website. How do you see the adoption with the OEMs primes? Well, that's the question was, what do I see in the way of adoption by the OEMs primes? That is the $64,000 question, or in this era, $64 million question. I am now seeing clear indications that the 2 or 3 of the largest OEMs are in the process either of already deploying an approach to APQP and PPAP, and it remains to be seen if they will tweak those approaches to bring them into alignment with AS9145. They're not that different. They're not that much of a deviation from AS9145. After all, the people who wrote AS9145 work for those companies, so there's a certain level of consistency. That is also true of some of the primes, the engine companies. Certainly all of them have some approach to APQP and PPAP that they have been deploying, and some of the larger prime structural and components companies are already, or have for several years, been deploying an approach to APQP. The question, the $64,000 question, is how much, if at all, are they going to modify their approaches to get to a consistent sort of conform to AS9145 approach, so that lower tier suppliers are not confronted with a variety of versions. They're moving in that direction. That's all I can tell you. I know that Omnex has been engaged in providing some training and orientation to some of those because of that movement, of the training on AS9145, because of that movement, because of the shift to say, if there's an international standard for this, maybe we should adopt that rather than creating our own. The OEMs and primes who created their own did it in a vacuum. They did it essentially saying, we need APQP and PPAP, and there isn't an aerospace version, so we'll make up our own. And they went to the automotive model. They followed the automotive model pretty closely, tweaked it over things like volumes, capability studies, number of samples, types, those sorts of things, and relaxed them a little bit, defining comprehensive design risk rather than explicitly saying you have to do a DFMEA. But in general, they're very close. What FAA or otherwise? The PPAP file goes through two steps. The question is, what FAA or otherwise person/role examines the PPAP file and when? As of yet, the FAA doesn't pay attention to PPAP, other than perhaps to acknowledge that it's there. The review and approval cycle is that the supplier, the producer of the part or component or system that is being PPAP'd, approves the package. They review it, and a member of management with authority to sign for the company reviews and signs a warrant saying basically everything in this submission is compliant to the requirements of the customer and the standard, and if there is a lack, there is documented and agreed upon plan to close that gap. The supplier reviews that, the supplier management signs off on it, it gets submitted to the customer, and the customer reviews it and accepts or rejects it or approves it on an interim basis. The word approval is being used because they're saying it's fully approved, it's approved on an interim basis, or it's rejected. But one of the critical things to understand about PPAP is the signal approval is the supplier's approval. The supplier, in fact, the document in various industries is referred to as a part submission warrant. And it is warranting the product, and it's not providing a warranty. It's warranting that the product provided in serial production will be produced in accordance with the evidence in this PPAP package, and if a change is required, there will be prior notice and approval to proceed, and to the degree necessary, a Delta PPAP submitted based on that. Let's see, I hope that answers that. And in terms of the question of when is prior to release for serial production? In theory, at least, you cannot ship serial production without an approved PPAP. In the aerospace industry, what that has been translated to mean is without an approved interim PPAP approval. And the reason for that is various in terms of engineering approvals and things like that. One PPAP requirement in an organization is you have a release for production drawing as part of the submission. Well, you can't get a release for production drawing until production parts have been tested and approved by the customer. So you ship them under an interim approval until you get that release for production drawing. So there are wrinkles like that that are going to necessitate interim approval. As a next question, as a make-to-print organization, how do you get the OEMs to give you more design info on what the product does, how it's meant to perform? Well, other than asking, begging, pleading, I will tell you that there is an awareness of this issue, at least, and that several of the primes that I've personally worked with are developing solutions for this. Some of that is actually involved engaging one of their PEs in the PFMEA work at the supplier, either in person or remotely by net meeting. The development of documentation that can convey risks associated with key characteristics, the effects of failure and their severity, as a document that comes along with the product definition and as an input to a PFMEA. But basically, joint multidisciplinary activities need to gradually become the rule rather than the exception. It's very common in the automotive industry to have joint APQP reviews up and down the supply chain, and I suspect that over time that practice will evolve, because otherwise the supplier has serious issues with trying to figure out what the relative risks are related to different features or characteristics on the product, absent knowledge of function, form, fit, function issues coming from the design responsible activity. It is an ongoing issue, and I don't blame you for asking about it. Trying to move on to the next question. What is the difference between level 2 and level 3 PPAP? There isn't, as far as I know, something by that name. What there are levels of submission. And levels of submission are level 1, the customer only requires the approval document. Level 2 is that the customer will accept just the approval document and whatever requested supporting data or information they want. A level 3 is the default level, which is a submission of the entire evidentiary package or making it available. The reason I say that is because a design responsible supplier is not likely to actually submit a DFMEA to their customer. What they'll do is say there is one and it's available for review at this location or whatever, but it's not leaving the premises. That may also be true of the PFMEA, by the way, in some contexts, because of confidentiality, intellectual property issues, and things like that. A level 4 is a review on site. That's where the customer comes to the vendor's production facility and either just reviews the package on site or actually witnesses the significant production run. In some cases, they may actually do a process readiness assessment prior to the initial production run, then witness the initial production run, and then review the PPAP package. That is not an uncommon practice in very high-risk either because the component or the system is very high risk, it's new, the process technology is new or novel, or the supplier has performed at a level of risk that the customer is concerned about. So they go to the supplier to try to get confidence in it. So those are the levels. Just the document with some data, the default level 3, which is the entire package, and level 4, which is conducting the entire review at the supplier's site. Okay, really good question. What happens when you want to improve the process and you need all that time to re-PPAP? Well, one, customers in the main don't want to discourage efforts to improve. So they don't want to say every time you tweak this or that or the other thing, you have to submit a complete new PPAP package. There are various practices that evolve around this. One of them is you lay out a plan to improve a process and they say, fine, when you're done and you've made all of those changes that say you've gone through your PFMEA and you've identified a number of changes and you say, fine, when you're done, we will have a PPAP review. The other is that it's a minor change, a low-risk change, and all you need to do is tweak the document and submit the approval form to the customer saying it didn't change anything. That will be worked out between you and your customer. But the main thing is they don't want you're not going to go through the entire PPAP process again for process changes. You're going to go through a review of those things that change. The rest of the package would remain valid. Where you're likely to go through a complete rehash of a PPAP package is when you move production from a plant in Illinois to a plant in Chengdu, China. Then you can pretty much count on doing a complete PPAP. Okay. But it's a good question. Here's another one. I'm not sure how to interpret this. I would not call this a spin-off from the aerospace industry. In fact, the automotive industry learned about FMEAs from the aerospace industry, which had neglected them, but the automotive industry said that might be a useful tool and picked it up. I think there's a lot of cross-pollinization, cross-fertilization, whatever term you want. They're all disciplines associated with risk management. The reality is that the automotive industry is so competitive that look what happened in the first decade of this. We had automotive companies that literally died and had to be resurrected because they weren't doing a good job of designing and manufacturing products. So they've been put through the ringer. The same thing is happening in aerospace today. I think there will be a consolidation. There's already a consolidation underway among the airframe companies. There will be a consolidation among the primes and the tier ones. You can count on it. And there will be a consolidation in the sub-tiers. And APQP and PPAP will be partly responsible for that. It will make for a gating issue that companies have to have a certain horsepower, a certain bandwidth to be able to do this. And it will challenge the very small companies that are specialists but have no real bandwidth and have been permitted for years to make parts in a context where it's on a piece-by-piece inspection basis, and there's a huge amount of risk associated with that. By the way, I'm going to have to call it a day because we've reached the end, but I will tell you that this is a much more complex subject than I can treat on in a 1 hour or hour and 15-minute webinar. We do offer a one-day overview, an executive overview for half a day, a full one-day overview, and a two-day in-depth look at AS9100, and of course we offer training in all of the core tools and contextualize them. But if you have a leadership team that really needs to understand this, I would suggest that you get them some form of formal orientation to understand it in depth, in particular to understand the value proposition involved. There's a very significant value proposition. There is gold in them thar hills, and that has been demonstrated by, you look around the world at some of the major automotive suppliers like Lear and Magna and Johnson Controls and those companies have become global. They've become multi-billion-dollar industries, and it's happened because they've become really good at what they do in every sense of the word, in terms of leanness, in terms of capability, in terms of product development, capacity and competency. And a lot of that has been a product of this consolidation that has been brought about in part by the deployment of APQP and PPAP. Anyway, on that note, since we are well past the time, I'll just take one more look at the questions. There may be, if there's one of my associates is pointing out to me that there is another one-day session in Seattle, Washington on April 26th. If you're interested, happen to be in that neighborhood or willing to travel to that neighborhood. And I've also been I and my associates have been doing this kind of training on site at a variety of facilities around the country for large groups of people representing their whole organization, or large chunks of information. And another individual has helpfully pointed out, if my explanation of the submission levels confused you, just look at page 17 of the PPAP manual for full details. Okay. On that note, obviously you need to study the standard. You need to have your associates study it. You need to understand how to make it a part of the way you do business, as opposed to what you have to do to keep your customer satisfied with paperwork. And on that note, I'm going to wish you all a really great weekend. We may actually get spring in some parts of the country that have yet to enjoy that, and that will be nice. For the rest of you, have a great weekend. Good day.